Hey guys, we're gonna start in about 5 minutes. Okay, so we're gonna do something a little bit different today. Um, this is another teacher that I know. He created this basically kind of practice test. It's 2 questions, and it's kind of just his example of like what possibly could be on the test. Um, And the reason he did this is he was trying to make a test that covered every single topic. And so his part one, instead of being like normally ABC or maybe ABCD, it goes all the way to ABCDEF. And his part two looks a little bit more normal. And that's because what they're kind of telling us right now is that part one is going to be worth 60% of your grade, and part two is going to be worth 40% of your grade. And then also, they're saying that they're going to give you 30 minutes for part one, or a little bit longer for part one than they are for part two. So that kind of is why that is. But at the same time, part one is extremely, extremely difficult. And I think honestly it's a little bit too difficult, but that doesn't mean that some of this stuff won't be useful to us and won't help us. So we're going to kind of look at it. What I'm going to do is, because it's such a crazy difficult question, I'm going to have us just go at it like one step at a time. So just part A, then just part B, then just part C. And I might even give you guys some hints at it. But I do want us to at least have time to try it on our own and to think through it. So let's do the same group, kind of breakout things that we did, but we're just gonna do it literally just one, like part A at a time. So for part A, I'm gonna just give you guys 4 minutes. If you guys probably need to take a screenshot right now. So I'll give you like 15 seconds, take a screenshot right now. It says let G be the function given by G of X equals F of X squared minus 5 for X is less than or equal to 3, 5 minus 2X for X greater than 3. And then it says the function is twice differentiable. It gives you that F of 6 equals negative 4. And then it also gives you the graph of F prime. The graph of F prime has horizontal tangent lines at X equals 2, X equals 5, X equals 8, and X equals 9. And the areas are labeled in that figure. So the first thing it asks is show that G is going to be continuous at X equals 3. This is a little bit of a weird take, but I'm going to give you guys 4 minutes to try that. And so hopefully you have your screenshot by now. So I'm going to put you guys in rooms, but you're just going to have 4 minutes, okay? Do you know where the pen is for my Surface?
Is this it? No. What does it look like? I don't even know. It looks like that. Oh, it's down here.
Hey Joseph, we're working on this guy part A right now. I only gave everyone 4 minutes, so I'm just gonna have you kind of read through it. Just try to read what's on the screen. And then if you can try part A, you can. If not, you'll just hear us when we join back.
don't know. Would you do the integral?
Yeah, that's what I did, and I got 6. I don't know if I did it wrong.
No, yeah, I think that's what you would do.
Yeah.
Cool. So I don't know if anyone got an answer or thinks they had an answer. I know that one was, to me, it was really, really tough. And it took me a long time to even solve it. I think this is probably too difficult for the AP exam, but it's good to go over because if we can do this, we'll be able to do a lot of other things as well. So give me some ideas, either hop on the microphone or in the chat. Give me some ideas of what you guys thought. Even if you don't have a full answer, just some things you tried.
Well, we were thinking of doing the limits test. So like, we'd do the G or limit of G of X approaching 3 from the right and 3 from the left, and then compare the two.
Okay, good. So you said the limit from the left, the limit from the right. Natalie's saying plug in G into 3. So let's just try that and see where it takes us. So it doesn't matter which one you do first, if you do plugging into G first or if you do the limits first, as long as you do both of them, because there are those 3 rules. So if we did what LV was suggesting, so the limit as X approaches 3 from the left of G of X equals, now, because this is less than, the top is less than, that's going to be our left side. Let's see if we can get... So that's our left. Oh, that's why. Okay. And 5 minus 2x would be our right. So because we have less than, we're going to plug into the top. And where this gets a little bit tricky is when we're plugging this into the top, it's F. So don't go too like far beyond. You still just need to keep in PEMDAS. So it's f of x squared minus 5, but because we're plugging in 3, that's going to become f of 3 squared minus 5. And so then that's going to give us f of 9 minus 5, so that's going to give us f of 4. And that's really basically the answer right there is f of 4. But we need to figure out what is f of 4. And this is what made this question a lot harder, is because generally the AP hasn't really asked something like that before, where you have to do the limits test or, you know, continuity, and then in addition, you have to apply FTC. So the reason we have to apply FTC is we don't have, f of 4 is not 0, right? This is f prime. We don't have an answer for f. So for f of 4, what we would then have to do is kind of do something like, okay, well, we know that f of 4 equals f of 6 plus the integral from 6 to 4 of f prime of x dx. I set this up with kind of, because when we do the integral, whatever we're looking for goes on top, and that quote unquote initial goes on bottom. But this does make our endpoints backwards, so we just want to be careful. You could have also just said the integral from 4 to 6 of f prime of x dx equals f of 6 minus f of 4. That's more traditional FTC. Either way you write that, you're going to get the same answer. And why did we pick 6 is because that's what they gave us. So that's the only point we know on the graph, so we have to use it. So from 6 to 4, because we want 4 and we know about 6. So in between 4 and 6, they tell us the area is 3. So if we did it the way I drew it in blue, right, then this would become f of 4 equals -4 plus, but then because you notice that your endpoints are backwards, right, 6 to 4, if I'm going backwards 6 to 4, that flips. Now it's a little weird because it's kind of double flipping. The area is 3, but because it's below, it's -3. But when we're going backwards, it turns back into +3. So that's a little bit weird. So it becomes -1. So again, the reason for that is when it's below, that means that if I go left to right, it would be -3. But if I go right to left, it would become +3. Because it was below the axis. If we did it this way I have in green, then we would get the area below is -3 equals -4 minus f of 4. We would add 4 to both sides. We'd get +1 equals negative f of 4. Divide by the negative, -1 equals f of 4. So either way we do this, we're going to get -1. So what that means for us, going back here, is that when we're doing this, that gives us the limit as x approaches 3 from the left side of g of x equals -1. Next, we're going to do the limit from the right side. So the limit as x approaches 3 from the right side of g of x. And for that one, we're going to use that side, right? The right side is the 5 minus 2x. So that's going to be 5 minus 2 times 3. That's 5 minus 6. That's -1. So because both the left and the right side limits were the same, we can say, therefore, the limit as x approaches 3, just overall, not the left or right, of g of x equals -1, and you might even add the word exists below it. Okay. So that's the first step. The second step, I'm going to just put up here, is to figure out g of 3. Okay, well, g of 3 is just going to be wherever it has the equal sign, which is right here. So I'm gonna just write g of 3 equals, when we plugged in 3, we do want to show that it's being plugged in. So when we plugged in 3, it was f of 4, and we solved for that and we got -1. And so then the third step is that those are equal to each other. So we can even say like, exists, right? Because the 3 rules are checking that the limit exists, that g exists, and they're equal. So now we can say the limit as x approaches 3 of g of x equals g of 3. Therefore, g of x is continuous at x equals 3. So we do want to make sure that we put this at part. That's important, that sometimes people forget. It's continuous at x equals 3. Writing exists isn't 100% necessary, but it's nice to show the reader that you know what's going on. What questions, if any, do we have on part A? I know that one was weird. To me, it was pretty tough, but I think it's actually a really good question.
So you took the integral from 6 to 4 because they already gave you f of 6?
Exactly. So whenever this is part of that whole like fundamental theorem of calculus, which is if I have f prime and I want f, we're taking an integral, right? Like we're going back up. So we're trying to get f of 4. And the only way to get f of 4 from f prime is to take an integral. And integrals will always have 2 endpoints, right? So if we're thinking like, okay, what are my 2 endpoints going to be? Well, they gave us 6, right? They gave us 6. So we know we're going to use 6 and we want 4. So those are the 2 points that I know about. So that's why I'm doing the integral from 4 to 6. Now it depends on which way I want to think about it to which way I set it up. It's really the same either way. It's just kind of personal preference. A lot of people like to always do FTC, which would have been saying, okay, we're just going to go the integral from 4 to 6 of f prime of x dx, because I know those 2 points, and that's going to become f of 6 minus f of 4, and then I can solve for f of 4 later once I plug everything else in. Other people like to just start off with f of 4, and if you start off with f of 4, that's okay. What you do is you put your other point here, which is f of 6, plus the integral, and then whatever you want to solve for is going to go on top, and whatever you have with it goes on bottom. It's the same formula, it's just written a little bit differently. But yeah, the reason we're taking an integral is because we had f prime, and the reason we use 4 and 6 are those are the 2 x values. That either one of them that we know and the other one that we want. What other questions do we have for part A? I think that was probably the hardest part right there, was just figuring out that f of 4. Okay, B, I'm not going to break us into groups for B. We're just going to kind of talk about it. So B says find the absolute minimum value of f on -2 to 10. So we want to find the absolute minimum of f on -2 to 10. Someone either in the comments or you can turn on your mic. How do you think we're going to start this question? What should be the first thing we write down before we even do anything else?
x equals 0. Oh, sorry, f of x equals 0?
Not f of x.
F prime.
Yeah. So we want the maximum of f, so it's always its derivative. So before we write anything else, yeah, f prime of x equal to 0. Thank you, Natalie and Elvia. Okay, so now where is f prime of x equal to 0?
X equals 0, 4, 6. Yeah.
Yeah, so it actually it kind of told us this. It said, oh no, it didn't. It gave the horizontal tangents. Yeah, 0, 4, 6, and we don't know for sure that that's 8, but because it said where it had horizontal tangent lines, those are these points over here. That's at 2, that's at 5, that's at 8, and so that has to be at 9. So we know it's 0, 4, 6, and 9. Now, this is something we can do to save us a little bit of time. We won't necessarily have to do it. But we can actually eliminate some of those when we make our table. And this isn't as common to do. Normally, I don't have you guys do this because it's not that difficult, especially when we have a calculator, to just plug everything in to be certain, but I'll kind of show us. So we have x and f of x for our table. What are the two other points we need to consider? Besides endpoints. So we're going to have -2, 0, 4, 6, 9, and 10. Wow, we really don't have enough room on this guy. Okay. Okay, so -2, 0, 4, 6, 9, and 10. And now what we can actually do, because that's so many points, is we can think, okay, where do maximums occur? They occur when our graph changes from increasing to decreasing, or when f prime changes from positive to negative. So if we go back up here, I'm going to erase some of this just to make it a little cleaner. Okay, if we go up here to our graph and we're looking at our graph, we're saying that a maximum would only occur when f prime changes from positive to negative. So the only time that actually happens is at 4, right? That's where, like if we drew a number line for this, between -2 and 10, and we put those numbers on here, 0, 4, 6, and 9. Between -2 and 0, it's negative. Then it becomes positive from 0 to 4. From 4 to 6, it's negative again. From 6 to 9, it's positive. And from 9 to 10, it's positive again. So if we were kind of thinking about that number line, that means that it goes decreasing, increasing, decreasing, increasing, increasing at a different rate. So the only possibilities for maximums are, for local maxes, it's only at 4, right? That's our only spot. But because we can also have endpoints, that means that the endpoints are also candidates. So what you could do is you'd have to kind of just write it out. But you could say x cannot be 0, 6, and 9 because f prime changes from negative to positive. So we're kind of eliminating those just so we do a little bit less work, right? So we know that for a local max, it has to change from positive to negative. Now, if you did all of those, it's not a big deal. You'll still get the points, but that would save us some work. So now how do we actually figure these out? Well, that's the same way that we did before. So the formula is essentially that f of whatever number we want, I'm going to just call it t. So f at some time t is equal to f of 6, which was negative 4, plus the integral from 6 to t of f prime of x dx. So I'm just that, you don't ever have to write that down ever. Okay, I'm writing that down just for us to kind of talk about. That's like a very generic formula. And that's essentially what we did up here. F of 4 equals f of 6 plus the integral from 6 to 4. I just changed our 4's to t so we could plug in anything. So for negative 2, we're going to get f at negative 2 equals negative 4 plus the integral from 6 to negative 2 of f prime of x dx. And if we wanted to set this up backwards, the way I said, you know, the integral from negative 2 to 6 of f prime and then do ftc, you could. So this gives us negative 4 plus the integral between 6 and negative 2. So if we go to our graph, we're going backwards. So 6 backwards all the way to negative 2. So this was below the axis, but since we're going backwards, it's going to kind of flip. So below the axis is going to be positive. So this first area is going to be positive 3 because we're going backwards. This second area is above. It said originally it was 11, but we're going to write it as negative 11 because we're going backwards. And this bottom area was 5, but because it's below and we're going backwards, we're going to make it positive 5. So positive 5, positive 3 makes positive 8. 8 minus 11 gives us negative 3. So that means this integral was negative 3. And negative 4 plus negative 3 gives us negative 7. Now, we can do that the same way for every single one, or we can do a little bit of a shortcut that I like on these, and that's essentially this, is we just did starting at 6 and going all the way back to negative 2. I want us to think about, let's just pretend we hadn't crossed out these other points, okay? We can cross them out and do less work, but let's pretend we hadn't crossed them out. If we want to get to 0 now, so if now our goal is to get to f of 0, well, before we said that if I go from 6 all the way back to negative 2, that gives us an answer of negative 7. Okay? But what did we say this area contributed? Because if we want to get to 0, that's just everything except for this positive 5. Right? It's positive 5 because it's going backwards. So it's everything besides the positive 5. So if we basically subtract off 5, then we would get negative 12. Now, it's a little weird. I'll kind of try to explain that again with the next one. So now what we're trying to do is we're trying to say, okay, next we want to get from 6 to 4. Okay, we already did this one. We know the answer is going to be negative 1. Okay, but we just found out that at 0, we had an answer of negative 12. So now, if we get rid of this 11, right, because we're not going to use it anymore, okay, and because we were going backwards, that means that we're going to add on 11 because we had been subtracting it. Then we would get negative 1. Now, you could just keep doing it out this way if you want to. That's fine. So for f of 6, the shortcut would be, and really, they give us f of 6 already as negative 4. But if we were using that shortcut, it would be that, okay, we already know about f of 4 is negative 1 here, right? So if I was kind of like thinking, right, f of negative 2, we would start at negative 7. Then we got negative 12. Then we got negative 1. Now we have an area of 3, but because it's below the axis and we were going backwards, we had been adding it. Now we're going to subtract it. So negative 1 minus 3 is negative 4. Or you can just look and see, hey, f of 6 is actually negative 4. For f of 9, okay, now we're here at negative 4, and to get to 9, we know that it's just adding on by 7. So now we're going to use adding because we're trying to go to the right. And we're at negative 4, and we're going to add on 7 more. Negative 4 plus 7 is positive 3. And then here we're going to add on 4 more. 4 plus 3 is 7. So I know I did something a little bit weird there, and I used the graph, but I just kind of wanted to show how that could be done differently. Now, again, this whole FTC thing, because I do really want to make sure, I think these are really important questions that are asked differently, but, you know, at a good level to practice. Had we just said, we're going to get rid of 0, we're going to get rid of 6, we're going to get rid of 9, and we want to figure out what is f of negative 2, we could definitely write this as negative 4 plus integral from negative 6 to negative 2 of f prime of x, which we did. Figure out that that integral is negative 3, which we did, and get negative 7. And we could have done the same thing for f of 4. And if you wrote it out because you forgot that they gave it to us, you would have just realized, hey, negative 6 to negative 6, that's 0. And maybe you realize, oh yeah, they did give it to us, and it's negative 4 because they gave it to us in the question. And f of 10 equals negative 4 plus the integral from negative 6 to 10 of f prime of x dx. And then that area from 6 all the way to 10 was 7 and 4. So 7 plus 4, which is 11. So negative 4 plus 11 is positive 7. So that's kind of one way to do it. The other way, essentially what I was doing was I was just figuring out, hey, this very first answer here, it was f of negative 2 equals 7. And really from the rest of the way, if I was starting here, I'm always going left to right. So what it always was anything new, if it's below, I subtract. If it's above, I add. Oh, this was negative 7, not 7. Right, so if I wanted to get f of 0, well, I have 5 below, so I'm going to subtract 5, and I'm now at negative 12. If I want to go to 4, then starting at negative 7, I would have subtracted 5 and then added 11, because I'm just going left to right. I know that's a little bit weird, it's just kind of another way to read these graphs. If you would rather just do it how I did it down here, that's okay also. I'm just trying to give us some different options. Okay, any questions on that? Part C is definitely weird. And I like part C a lot and I don't like part C a lot. And it's because there's kind of a weird thing about it. So it says for x is not equal to 3, the function k is defined by k of x equals 3 times the integral from 4 to 3x of f prime of t dt minus 4x all over 3e to the 2 f of x plus 5 minus x. It is known that the limit as x approaches 3 of k of x can be used evaluating L'Hopital's rule. Find f of 3 and the limit as x approaches 3 of k of x. Okay. And this is a really weird question that honestly, I've never seen them ask this on AB, which is why we haven't gone over it. It's not to say that they can't ask it, it's just that they never have. I know this year is a little bit different. So who knows, which is why this teacher kind of put it on this test and we're going to go over it. So the hint that they give us is it says, it is known that the limit can be evaluated using L'Hopital's rule. Well, what's the condition for L'Hopital's rule? What has to happen for us to use L'Hopital's rule?
There has to be a 0 in the denominator.
And in the numerator, and both.
Yeah.
Right. L'Hopital's rule is when the limit equals 0 over 0. So they basically, without telling us, they're basically telling us that if we plug in 3, that the top is going to equal to 0 and the bottom is equal to 0. Now we want to solve for f of 3. So where do we see just regular f of x is in the denominator. So to solve for f of 3, we're going to take the denominator and we're going to set it equal to 0 because that was kind of the hint that they gave us. I think that's a really hard thing to do, but you know, basically that's what that is. So we're going to say 3e to the 2 f of 3 plus 5 minus x, and we're going to put 3 for x equals 0. If you wanted to write those as x's first, you could. You know, I guess you could write, if you really wanted to like really be showing your work, we could have written that the limit as x approaches 3 of 3e to the 2 f of x plus 5 minus x has to equal 0 because of L'Hopital's. So that would be really explaining it. I don't think you'd have to do that. Anyways, that gives us 3e to the 2 f of 3 plus 5 minus 3 equals to 0. We're going to add 3 over, and I'm going to skip a step. I'm going to add 3, and then I'm going to divide by that 3. So that's going to give us e to the 2 f of 3 plus 5 equals, we added 3, but then we divided by 3, so we're going to equal it to 1. Okay. How am I going to solve this when I have an e in it? How am I going to isolate when I have an e in it? What do I need to do? How do I get rid of e?
Use ln.
So take the ln of both sides. Good. And so then that gives us, these cancel. So that gives us 2 f of 3 plus 5. And ln of 1 is something that we need to memorize. Actually, we don't fully need to memorize it, I guess. It's nice to memorize it. But since ours is going to kind of be open book, open calculator, we could just type it in and we would get 0. And on this question, let's say this was on our test, you really could write this line, and because we have open calculator, you could from there, I think, I'm going to ask this question. There's going to be another AP meeting. And so I'll try to ask this question, but you should be able to just use your calculator right then and there. The issue is that it's f of 3. And what are we solving for? We're solving for f of 3. But essentially what you would want to do on your calculator would be to, we're going to use the solve button. And we had 3, e to the 2f of x, right? And it was f of 3. But f of 3 is what we're going to solve for. So I'm going to just call that our x, right? So I'm calling that f of 3 our x. So 2f of 3, but because we want that, we're going to call it x plus 5 minus 3 equals to 0, comma x. And we should get an answer, -5/2. Let's see if that's what we get. So now we have 2f of 3 plus 5. We can kind of see we're going to subtract 5, divide by 2. So we do get -5/2. So I kind of showed it by hand, but you could have also done that on your calculator. But just making sure you know, hey, that's what I'm solving for. So I need to make that my x. Okay, so anyways, it asked for 2 things. First, it said find f of 3. We did that, we got -5/2. Second, it said to find the limit as x approaches 3 of k of x. So we know that L'Hopital's rule applies, right? So we know that if I plug in 3 to the top and 3 to the bottom, I'm going to get 0 over 0. So you could try that, but you're kind of just wasting your time because they told us we're going to do L'Hopital's rule anyways. So L'Hopital's rule is when we take the derivative of the top and the derivative of the bottom. So the derivatives are a little bit tricky. This is using that other FTC, which is when we take the derivative of this, we plug in 3x, but we also have to do chain rule on it. So there are going to be 2 3's here. There's going to be the first 3 from the beginning, and times the second 3 for that chain rule, and then times we're going to plug in f prime of 3x. And that's just for the integral part, right? The integral ends here at dt. We're not plugging in 3x to 4 because this is like, the dt is like ending the integral. So minus the derivative of 4x is 4. All over. And really, actually, we should have, I made a mistake that a lot of you guys might make. Does anyone see the mistake I made? I'll wait till the end and then I'll
You
give you a
plugged in 3 already with the limit?
Not yet. I'll go over. I'm gonna do the derivative of the bottom first, and then we'll go over my mistake. So the derivative of the bottom, anytime we're taking the integral of an e, we do chain rule on it. So it's 3 e to the box, right? So we're gonna leave everything the same. E to the 2 f of x plus 5 times, oh, I wrote that wrong. 2 f of x plus 5, and then times the derivative of the box, so the derivative of the top is 2 f prime of x. and then minus the derivative of x is minus 1, right? Because that's separate. Okay, what am I missing that I forgot to do? Anytime we're doing limits, we have to do something every single time we have an x. We have to rewrite the word limit as x approaches 3, right? When we do L'Hopital's, we have to rewrite that limit, the word limit x approaches 3. Now we can go ahead and plug in 3. So now we can plug in 3. 3 times 3 gives us 9. F prime of 3x would be times f prime of 9. Okay, well, we had a graph up here. And on this graph, 9 was, right, this is the graph of f prime. 9 was one of my zeros. So f prime of 9 was 0. So I'm going to just put 9 times 0 minus 4 all over. And 3 e to the 2 times f of 3, because we're plugging in 3. Okay, and f of 3 is what we just solved for. So we just solved for f of 3 and we got negative 5 halves. So negative 5 halves plus 5 minus 1. Well, 2 times negative 5 halves, the 2's are going to cancel. And so that's e to the negative 5 plus 5, so that's actually e to the 0. So that goes to 0. All right, let's use another color. So that went to 0. So on the top, we get negative 4. And on the bottom, this whole thing, 2e to the negative 5 halves plus 5, that whole thing went to 0. So it's like e to the 0, which is 1. So this is 3 times e to the 0 is 1. So 3 minus 1 is 2. And then, did I mess something up? I totally forgot to write this part. I knew I messed that up. Okay. So that's my fault. I forgot in here. I know this is getting kind of messy. Okay, I'm going to write in red just to make sure we know. So this is negative 5 halves plus 5. I forgot this part here. Times 2f prime of 3. So f prime of 3, because we're plugging in 3 now. Okay, f prime up here on the graph they gave us was 3.5. So times 2 times 3.5, and then minus 1. So again, this went to 0. This whole part up here went to 0. So that gives us on top negative 4, and on bottom 3 times 2 is 6. And then times 3.5, you would do it on the side, will be 21. You also do this first. 2 times 3.5 is 7. 7 times 3 is 21. And 21 minus 1 is 20. You can just leave your answer just like that. Okay, which is negative 1/5. You have a calculator, so honestly, I would just plug it into your calculator. I know that one was a little bit funky. Okay, we got D and E and F. I know we're kind of running out of time, but I don't want you guys to do this for homework. So let's do these as fast as we can. I'm going to go through them a little faster. So this says let y equals h of x be a function given by dy dx equals f prime of 2x times 3y minus 1. Find d squared y dx squared and use this to determine if the graph is concave up or concave down. So they want us to do the second derivative. Well, we have the first derivative. So if we're going to do the second derivative and we see multiplying, that's product rule. But we also see this y in here, so that's going to be implicit. So this one's a little bit weird. So we take the second derivative. The first part is going to be f prime of 2x times 2. and then times the original of the second, which was 3y minus 1. Then plus for product rule, now we're going to, oh, this should have been f double prime of 2x. F double prime of 2x, because it's the derivative of f prime, right? The derivative of f prime will be f double prime. Okay, then the second one, we're going to leave the first alone. So f prime of 2x is going to be left alone. And times the derivative of 3y will become 3 dy dx. Now, what is dy dx? It's this whole thing, right? It's the whole thing again. So that gets a little bit weird, but we don't really have to replug it all in here, because what we know is we're just trying to plug in the point 1 comma 2, right? They want us to, it says find d squared y dx squared, and then use that to figure out if it's concave up or concave down. So yeah, I guess they do want us to do that. So we're gonna put equals, I'm gonna move the 2 to the front. So 2 f double prime of 2x times 3y minus 1 plus, and then I'm going to move the 3 to the front. I'm going to say 3 f prime of 2x. And for dy dx, I'm going to put another f prime of 2x times 3y minus 1. Because what I'm doing is, instead of writing dy dx, we're rewriting that whole thing. So now we found d squared y dx squared. So that was part 1, and then we're going to use that to find h of 1 equals 2, or the derivative, the second derivative there. So anywhere we see an x, we're going to plug in 1. Anywhere we see a y, we're going to plug in 2. So that means that this is going to become, and again, there's not a whole lot of room here, so I'm going to just write it down here. That's going to become 2f double prime of 2 times 1 is 2, times 3 times 2 is 6. 6 minus 1 gives us 5, plus 3 f prime of 2 times 1 again gives us 2, times another f prime of 2, times 3 times 2 gave us 6, minus 1 was 5. Okay, and we don't know what f double prime of 2 is. There wasn't really anything about f double prime, but we do have this graph, and f double prime at 2 would be here. Well, f double prime is going to be the derivative of this graph. Well, up here, the derivative of this graph, because it's a horizontal tangent line, is 0. So we know that f double prime of 2 is 0 because its derivative is 0. It also said the graph f prime has a horizontal tangent line at 2. So that part's going to go to 0, so that whole thing will become 0. So now we just have the right side. So plus 3 f prime of 2. F prime of 2 is literally going to be the y value, because they gave us that graph. So the y value is 5. So 3 times 5 from this guy times 5 from that guy. So that's 125 times 3, which is 375. So that was our answer. Now we're still not done, because they said use that to figure out, is it concave up or concave down? We're going to say concave up, because d squared y dx squared at 1, 2, you don't have to write it like that, was equal to 375, which is greater than 0, or positive. Any questions on that one? I'm going to try to move on because I want to make sure we finish in the next couple minutes. I was a little bit weird. I will post this video if you guys want to rewatch it. I'm going to erase this to give us some room. So the next question says, considering that function, where is h of x increasing? So we still have that same function, whereas h of x increasing. Well, when we're doing increasing, decreasing, we're just setting it equal to 0 and then doing a number line. So h of x was, from part D, was this function. So we want to basically say, okay, h prime of x needs to be equal to 0, which is f prime of 2x times 3 minus y minus 1 needs to be equal to 0. So that's a little bit interesting. And basically what's going to happen is either the f prime of 2x part can equal 0, or the 3y minus 1 part can equal 0. So, right, if either one of those two, if this is 0, the whole thing will be 0, or if this is 0, the whole thing will be 0. So I'm going to kind of write f prime of 2x would equal 0, or 3y minus 1 would need to equal 0. And let's just kind of take those one at a time. So for f prime of 2x is 0, really, if we look at that, it's saying, where is f prime 0? So where is f prime 0? It's 0 at 0, at 4, at 6, and at 9 is where it's equal to 0. So that's where f prime is 0. But because we have 2x, we need to divide all of those by 2. So that gets this one a little bit different. Now actually kind of looking at the time, I don't want to, E is going to take a while, F is going to take even longer. And I promised you guys we'd be out, so I don't want to do these. So what we're going to do is we're going to save E and F. We're going to save them for tomorrow, because I don't want to take another 30 minutes for you guys. So question 2 is a lot easier. If you guys look at question 2, it honestly looks like what you guys have done a million times. Okay, it gives us a table. It says use the data in the table to approximate C double prime of 7 using correct units. Explain it. When would it, use the table? Does it support this conclusion? Think about what that kind of hints at you. When they word it like that, that's something that we've talked about, is hinting that you should use a certain theorem or a certain formula. Part C is just a right Riemann sum. And part D, they give us an equation and we have to use that equation. We've done this type of question a bunch of times. So this is our only homework, but the catch is that there are no answers. And you guys can use Google, you can use your notes. If you really want to work with friends, you can, but that won't be totally how we're going to do it on the AP exam, but we're not quite there yet. So if you want to, you'll hop on a call with some friends, you can do that. But if you really want to practice, a good practice for this question would be to basically get everything out that you want to, get your calculator out or your laptop out or whatever you want to be using out, and then set a 15-minute timer and see how much you can do in that 15 minutes. Now, if you want to keep working after that, you can, but that's just a way for you to kind of get some practice there on your own. Okay. So for you guys who are here, your homework's going to be AB2. If you want to redo on here, what I'm going to assign for the whole class is to do A through D. Okay, we'll talk about E and F in tomorrow's video, but I'm going to assign to the class A through D. If you guys want to redo those, honestly, they're not bad practice because these were really difficult questions, and redoing them on your own might help you out and help you to understand it better. I'm not going to require that from you guys because you were here in the video and you watched it. But if you want to redo it, I think that would be great. Great practice. So again, our homework is optional. Redo A through D from part 1. Mandatory, do part 2. Everyone else, and what I'm going to post online is you're doing both of those. But if you're listening right now, you know that all you have to actually do, I took a screenshot just now of everyone in the room, is just do the second question. All right. We're done. I know I went through that fast, so if anyone wants to stay on and ask any questions about part 1, if something confused you, you can stay on and ask me a question right now. Otherwise, feel free to log off.